Welcome back, folks. One more mesh analysis video. I just couldn't help myself. You know, early when I was first introducing mesh analysis, I said that I was going to give you the basic steps, and at the very end I was going to kind of summarize everything, because there's a lot of little special cases and stuff that you got to keep track of. I've put that all into a document. It's a little over a page. It's in the unedited lecture notes on the course website. So I just want to pull that up and kind of walk through that together so that you see how everything we've learned over these last, I think it was 19 videos, hangs together so that you can look at a circuit, make a plan, and then go execute that plan to do the analysis, because that's what is going to make you feel confident. When you see any circuit, you're going to be able to go do the analysis that way. Okay, so somewhere in the course materials, find that. It's probably on my website, which I'm going to edit a lot before you even look at this video. So I don't know exactly where it's going to be, but I'll make sure it's prominent. It'll be strategy for mesh analysis. Strategy for mesh analysis. Here we go. Okay, and it looks something like this. Right now it's section 7.8. This is such an unedited draft thing. It could move by the time I get around to putting this together in its final form. Okay, so when I first look at a problem and I'm considering using mesh analysis, the first thing I do is count the meshes, because that's going to define how many unknowns that I need to solve for, and that tells me how many equations that I'm going to need during my analysis. The next thing I notice is, are there any current supplies? Okay, because if I see a current supply, I know I'm going to write a KCL equation. I didn't say dependent current supply. I didn't say independent current supply. I said current supply. Okay, so look for a supply with an arrow in the middle. Doesn't matter what kind. Okay, does it touch a single mesh? If it touches a single mesh, then I write a KCL, and all of the other equations I write the same way that I would have with KVLs. If it touches two mesh currents, then I have a super loop, sometimes called a super mesh, depending on which textbook you're looking at. You're going to write the KCL the same way, but when you write the KVL, you take the two currents that touch the current supply, the two mesh currents that touch the current supply, and you stick them together, and you write the KVL around the loop that encompasses the two meshes. Okay, so that's a little bit of a wrinkle there that we didn't talk about when I first introduced the steps. So I like this summary form better, and I encourage you to use it when you're working your homework problems. Okay, the next thing I notice are any dependent supplies. So I'm looking for anything that's in a diamond, right? It's a voltage supply if it has the plus and minus inside the diamond. It's a current supply if it has an arrow inside the diamond. But if I see a dependent supply, I know I'm going to have to find the control variable somewhere else in the circuit, write the expression for that control variable, and then substitute that into the equation at some point so that I can get down to a system of equations that has only constants and only unknown mesh currents. Okay? Once I have a system that fits that form, then we solve it. MATLAB, Python, TI calculator, some of you have Casios, whatever you can, go ahead and solve that system of equations. Use the tool that you need to use when your job is on the line. Okay? Solve it, you'll get the mesh currents. Once you have the mesh currents, then you got to do something with them. You're trying to find the value of interest in your analysis. So we got to find the output. If the values are current, that's kind of the easiest one when it comes to mesh analysis. Play the same game. Does the mesh current touch your output current? Does it go in the same or opposite direction? All right, and write the KCL the same way you would write it as we did previously. Okay, if it's a voltage, now we got a couple options here. If it's a voltage across a single passive component, then we can use Ohm's law. Right now we only have resistors for passive components, but we're going to add capacitors and inductors in a little bit, and this is still going to hold. Okay, so if it's across a single component, you can use Ohm's law, which is great. Find the current, multiply by the resistance, you get your voltage. If it's across multiple components, or if it's across a current supply, then you're going to have to write a KVL that includes the unknown voltage. And you'll have to use some of the other techniques to find some of the voltage drops, right? So if that loop that includes the unknown voltage has a resistor in it, you might need to go back and find the voltage across that resistor using one of the previous methods that I just mentioned. Okay, so look at this summary, kind of make it part of your soul, at least for the exam. But if you're going to end up doing a lot of this stuff, and you certainly will in some of your future classes, this is a good sheet to remind yourself of what to look for and what to do about it when you're performing mesh analysis. Okay, so hopefully this is helpful. Pay attention to the sheet. I think that's even more important than me talking about it. Really, I just recorded this so that you would be aware of it and you know what it looks like. Okay, so on to nodal analysis. I'm excited. Stay tuned and good luck.